So this video is going to be going over the 2-1-2 homework, angles formed by transversals. In 219, you want to find the relationship. So what is the geometric relationship between labeled angles, and what is the relationship of their measures? Then use the relationship to write an equation. So these angles in part A are vertical angles. So I'm going to write vertical angles. And then what does that mean about their measures? So they're called vertical angles, and vertical angles are always congruent. Let's say equal. They're always equal. And so since vertical angles are always equal, let's set up an equation that says they equal one another. So 3x plus 5 should equal 5x minus 57. And so now we have an equation where we can solve for x. So I'm going to go ahead and subtract 3x from both sides. 5 is equal to 2x minus 57. Now I'm going to go ahead and add 57 to both sides to isolate the x value. So 62, and then I can go ahead and divide by 2 to find x is equal to 31. All right, and then for part B, these two angles, they form this straight line together. So that means these two angles are known as supplementary angles. So we're going to say supplementary angles are angles that add to 180. So now I'm going to write a mathematical sentence, an equation that shows that these two things should add up to 180. That's a 4, right? Yes. So 4x plus 150 plus 2x should equal 180. So I added those two angles together. So here's the angle on the top right, and then here's that angle on the top left. You don't need to put the parentheses there. I'm just trying to show you that I'm adding the two angles together. So let's combine our like terms. So our like terms would be a positive 2x and a positive 4x. So that'll get us 6x plus 150, and then bring down the 180. We need to get the x by itself, so we'll do the subtraction of 150 to get x is equal to 30, and then we'll divide by 6 to find x is going to be 5. Now you can always check your work by plugging this 5 back into here and seeing that they add up to 180 degrees. So you can always double check your work that way. All right, I don't want to make this video too long, so I'm not going to do that, but you can do that. All right, in problem 20, you determine that because an isosceles triangle has reflection symmetry, then it must have two equal angles. How can you tell which angles have equal measure? For example, in the diagram at the right, which angles must have equal measure? Name the angles and explain how you know. So this is an isosceles triangle. Well, we know that we can draw in the reflection symmetry, or the line of reflection, or the line of symmetry. We can draw in here because this is where you would have to fold that figure so that it sits on top of itself and it's equal on both sides. And so then if these two sides are equal to each other, these angles are always going to be equal to each other too, because if you were to fold it, the C and the B would match up on itself exactly. So name the angles, explain how you know. So we can say angles C and B are equal, and if you want, you could just say angle C is equal to angle B, and then we know because of the reflection symmetry. You might notice that this textbook it is a little redundant. So a lot of times it's going to tell you the answer, and then you just have to reflect back and kind of like repeat the answer itself. And that's okay. It's even though it's there already, it just wants to make sure that you're thinking about it and wants to give you time to reflect, and that's why it asks you those questions. So now in part B, we're going to examine part A, the diagram, which is the same diagram. So if you know that the measure of angle B plus the measure of angle 4 is 124, then what is the measure of angle B? Explain how you know. So if we take a look at this equation right here, that is the given information. That's what they're telling us. Well, we just talked about how C is equal to B. So if we're trying to find the measure of angle B using this equation, what we can do is we can use substitution, and we can say, hey, C is equal to B. We just said that. So let's rewrite this equation by using substitution. So we can say, hey, that means the measure of angle B plus the measure of angle B should equal to 124, because we talked about how B and C have to be equal, so I should be able to replace one with the other. Just like if you were solving a system of equations. All right, so now what we can do is we can combine your like terms. So we have it in the measure of angle B plus the measure of angle B. So really we have two measures of angle B, which will equal 124 together. And so if I want to solve for the measure of angle B and get the measure of angle B by itself, I can go ahead and divide that 2 to get the measure of angle B alone. So now I have the measure of angle B should equal 124 divided by 2, which would give us 62. So that means the measure of angle B has to be 62 degrees. And so explain how you know. You can use words to explain how you know. If you show your work, kind of like how I did with replacing angle B with angle C, and you show me each step, that's you explaining it. So you can, if you would prefer to do it in words, you can, or if you would prefer to do it in mathematical equations, that would be fine as well. So it wants us to use this idea to find the value of x in the diagram at the right for part C. So I'm going to go ahead and zoom in so it's a little bit easier to access for me. So if these two lines are the same tick marks, that means those sides are equal to each other. And if I were to draw in that line of symmetry, you would see that the base angles have to be equal to one another. I'm going to go ahead and erase this line so I've got a little more room to work with. And so then I could also say that this angle has to measure 71 degrees because those angles have to be the same. Now what we can do is we can look at the fact that these two angles here form this straight angle, which should measure 180 degrees. So these two angles should add up to 180 because they're supplementary. So I'm going to say 71 plus the angle or measure of x should add up to 180 degrees. Now what I can do is I can subtract 71 to get x by itself. And so let's carry the 7, carry the 1, 9, 109. So then x would have to be the measure of 109 degrees. There we go. Let's make sure we answer the question. Use this idea to find the value of x in the diagram. Be sure to show your work. So there we go. All right, for number 21 on the graph, we want to draw the quadrilateral with these vertices. So -1, 3. Then we have 4, 3. -1, -2. And 4, -2. Draw the quadrilateral. So quadrilateral has 4 sides. This does have 4 sides. what kind of quadrilateral is this? So this wants us to be specific. So we learned about quite a few different kind of quadrilaterals. We talked about parallelograms. We talked about squares. We talked about rectangles, trapezoids. What else? Isosceles trapezoids. A kite. And a rhombus. Wow, there's a lot. So these are all of the quadrilaterals we've talked about in our like so-called shape bucket. And so we want to figure out what kind of quadrilateral it is. I would start by noticing that all of these angles are right angles. Okay. Then I would find the side lengths. So the top is 1, 2, 3, 4, length of 5. The right side, 1, 2, 3, 4, 5, 6. The bottom, 1, 2, 3, 4, 5, 6. I must have counted wrong. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I did. I counted wrong. 5. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. Okay. So what is a shape? Which one of these shapes have right angles? Well, a parallelogram does not always have right angles. A trapezoid does not always have right angles. A kite does not. An isosceles trapezoid and a rhombus. None of those will always have right angles. So that's why I'm going to cross all those out. Now we have a rectangle and we have a square. Well, this is a rectangle because opposite sides are congruent. You have 4 right angles. It's a quadrilateral, but more specifically, we can say that this rectangle is a square because it has equal sides. All of the sides are the same length, and that doesn't just happen in any rectangle, it happens in a square. So that's why I would say that this quadrilateral would have to be a square. Translate the quadrilateral 3 units to the left and 2 units up. What are the new vertices? All right, so I'm going to use a different color here, and it wants us to go 3 units to the left and 2 up. Okay, so I'm going to start at my top left corner, and then I'll go around. So 3 units to the left, 1, 2, 3, and 2 units up, 1, 2. And so what we're going to do is move each point like that. So 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. And then 1, 2, 3, 1, 2. And so now here is your translation based on what they asked you. So now we need to do the new coordinates. So I'm going to start with, you know what, I'm going to label these A prime because that's the new point. So I'm going to say that that's at -4, 5. And then let's label this B prime. So B prime is going to be at 1, 5. C prime, we'll make this C prime. C prime would be at 1, 0. And then D prime would be at -4, 0. All right. 22, find the equation for the line that passes through. I think this is the last one. All right, so when we find an equation that passes through these points, let's see, -1, -2 would be here. 4, 3 here. All right, so I'm going to go ahead and draw in a straight line here that I can. Okay, it's not the best, but it'll do. So is 3, 1 on this line? Be sure to justify your answer. So we have to write the equation. Let's go ahead and write the equation first. So we're not given the y-intercept. And rather than guess what the y-intercept is, what I would suggest doing is first writing out how do you write an equation. So we usually start with y equals mx plus b. We need two things. We need the slope, which is your m value, and then we also need your y-intercept. Okay. So let's find the slope by using the slope triangle or by finding the slope triangle. So you would start at one point and see how much you have to move up and to the right to get to that next point, or up and to the left. So here's my slope triangle. So I had to go up 1, 2, 3, 4, 5. And then I had to go to the right 1, 2, 3, 4, 5. So 5 over 5 is my slope. They're both positive because I'm going up and to the right. And then if you reduce 5 over 5, you get a slope of 1. So actually, if my slope is 1, I could say rise 1, run 1. So I can say rise 1, run. Rise 1, run 1. Rise 1, run 1. And so then I can find all of my points on that line, or most of my points that can be shown. So I can use that slope. So now look, hey, here's my y-intercept. It's at a nice exact position. So I can say, hey, that y-intercept is going to be when your x value is 0 and your y value is a -1, because we had to go down. So now I can say my y-intercept is a -1. And now we can plug those values back into this y equals mx plus b. So y equals my slope, which is 1. You can write the 1. You don't have to write it. You can just say y equals x. And then your b value is a -1. So this is your equation. If you want to write it without the 1 in front of the x like that, that would be fine. So either one of those equations will work for me. Is 3, 1 on this line? I'm going to get the green marker out. So we want to find point 3, 1. So 3, 1, you start at the origin when you find locating a point. So 3 to the right. So remember you have to go in the elevator before you can go up or down. So when we're plotting a point, you have to go left or right before you can go up or down. So that point was 3, 1. So I'm going to go 3 to the right, and then I'm going to go up 1 to get to 3, 1. So what happened at that point? 3, 1, which is right here. So is this point on the line? No, it is not. So we can say no. Be sure to justify your answer. Well, showing you in my work, I'm justifying my answer. So you can't talk. I mean, I'm justifying my answer by talking, but you can be drawing all of these things on your graph or on your picture to let me know that no, it's not. I can clearly see that that green point is not on that line. What you can also do is remember that this point, each point has an x and a y value, so we can plug that into the equation if we wanted. So if we wanted to plug that stuff in down here and say, okay, y is 1 equals your 1 times your x value, which is 3 minus 1. And so if we reduce the right side, we're going to get 3 minus 1, which is 2. So does 1 equal 2? No. And so since this point does not work inside of that equation, and it doesn't make it true, that means it's not on the line if it doesn't make the equation true. If it does make the equation true, that means it is on the line. So that's how you can test it out. All right.